We're now going to look at working with two relationships on a set of axes. And in order to do this, what we're heading towards is finding the point of intersection of two linear or line graphs, linear function line graphs. And this is on page 26. A good example to use for this is paying for electricity. So there are two ways of paying for electricity. The postpaid, which means you pay after you have used your electricity, or the prepaid, you go and pay for your electricity before you use it. Right, the postpaid system, there is a service fee provided because they will do the electricity meters, so obviously there's work involved there. You get charged a base fee for that, and then you will get charged per unit of electricity, per kilowatt hour of electricity, which gets added to that. This is similar to a contract cell phone. Prepaid, there's no fixed amount charged because you go to the supermarket or you go to the shops wherever you buy your electricity, so you buy it and you load it yourself. There is a higher rate for electricity used on the prepaid system. Right, and we do that to talk about a break-even analysis. So this is the beginning of our break-even analysis, and break-even is where two graphs intersect. So let's have a look at the first one. You will see over here, your break-even point is approximately there. So graph B is the blue graph, a different cell phone system, and you will see that the blue graph starts at 100 Rand, so you know that this is the post-paid system because there is a service fee of 100 Rand involved there. Graph A is the one rate system, which is prepaid. And how do we know that? Well, if I use no electricity, I pay no money. And you will see right up until this point here, which if I read over there, graph A is cheaper because it lies behind or below graph B. So let's have a look at another way of representing it. The account is lower, so the account is lower, this graph is lower, up until that is about 720 units. So from this we can see that if I use less than 750, or let's call it, 750, then it would be cheaper for me to buy the prepaid system. But if I use more than 750, it would be cheaper to use the postpaid system. Right, this graph is not beautifully drawn because naught is over there, and that is not how we draw our graphs. So we should have started, the one graph should have started here, and then your other graph should have started over here. Okay, so this point here is called the break-even point. And that is the only place you're ever going to write where you took your reading. So the break-even point, you are often asked to label it with the letter A or B or X. That is how you would label it. Right, in order to draw those graphs, you were given this type of information. So the postpaid means you pay after using. There is a fixed amount, because remember there's work involved. They've got to generate the accounts, they've got to come and read your electricity, etc., etc. So you pay a fixed amount or a base fee of 291.80. The tariff thereafter. So when we deal with finance, you will see we're now getting to values that are more than just 2 decimal places. And remember, you round off at the final stage of your answer. And you can see, just as we said, the tariff for postpaid is only about 59 cents per unit, and the unit for electricity is kilowatt hours. So kilowatt hours is the unit for electricity, whereas the prepaid, there's no initial cost, but you are paying nearly R1, 0.995025 per unit, which is R1 basically per unit. So you will be given a table like this. You must be able to complete the table, you must be able to write the equation, and then you must be able to draw the graph. So the postpaid cost, we know there is a base fee. So if we have a base fee, our postpaid is going to have our base fee, which is 291.80. That is what I pay irrespective of using electricity or not. Then I'm going to add, and this, we write that, so units used, and we are going to multiply it by 0.589699. That is the equation to find the postpaid. To find the prepaid, the cost will be, it is purely going to be 0.995025, and we're going to multiply that by the number of units, or the units used. And that is how you will find the values for the prepaid cost. Right, and also we know from this kind of scenario that if I use no units and I put it into my equation, so for no units, my postpaid is still going to be, and I'm not going to put rand because I've got my rand sign over here. So that's going to be 291.80. So I've used no electricity, but I have to pay that. And remember, when we get a graph like that, we also know 0 units, I'm going to start at 291.80. So that you should have in the back of your mind immediately. Right, then I go and work it out for 100 units. So let's go. I would have to say 100 multiplied by 0.58966, and then I'm going to add 291 to that, and I will get 350.77. I do the same units. I'm using 200 units. So I say 200 multiplied by 0.589699, and I will get 409.74. With 300, I would get 468. Please check that you know how to do this. 71. 400, I would pay 527.68. 500 is going to be 586.65, and so on. Right, the prepaid, all I'm going to do is I'm going to take 0 multiplied by 0.995025, and I will get 0. Remember, no units used or no units bought, I pay nothing. For 100, it is going to be 99 rand and 1 cent. And 50 cents. For 200, it will be 199.01. For 300, it's going to be 298.51. For 400, it's going to be 398.01. For 500, it is going to be 497.51. Right, now from the table, we can see that I haven't reached the break-even point yet. So I would have to extend my table, and I would carry on. I'm going to give you the value for 800 units used. It would be 763.56, and the prepaid would be 796.02. So all the way up to this point, prepaid was less. As soon as I go higher up, it becomes more. Right, let's have a look at the observations. What do you notice about the cost if no electricity has been used? So no electricity used, as I said, post-paid, you still have to pay your 291. Your prepaid, no electricity, I pay nothing. The prepaid system is cheaper until, well, we have to draw the graph. If I had to have all the values, we would be able to see here, but at this point in time, we can't say. When would it be more economical to use the postpaid? So this is why we need to draw these graphs so that we can answer these two questions. Right, let's have a look here. So I have filled in all the values for you. I'm going to use the blue was the prepaid. And how do I know which is prepaid? Well, prepaid, if there is no electricity used, then you pay nothing. So this is the prepaid, and then this one here is the postpaid. And you can see we've started at 291.80 cents. And again, I'm just going to repeat that these intersections must all be the same distance apart, and you can see I've gone up in hundreds to 900. At the bottom, so in other words, I would have to fill in my labels. So this is amount in rands. This is units, and that's in kilowatt hours. Okay, and we have to identify the point of intersection and label it. So this is my, let me just rub these lines out. So this is my point of intersection, and I'm going to label it with an A. So what that means is, at A, if I had to take a ruler and draw my line down to the bottom, over there, that would mean that they both cost the same for about 780 units. And what does it mean? How much will that cost? Well, I would take my line and I would draw it across here. Sorry, just moved a little bit. I would draw this line here, and you always need to label your graphs, and that would be approximately 700. That would probably be about 750 Rand, and that is where that is taken. So often what I ask you is identify the break-even point and explain what is happening here. So the break-even point is A, and what that means is A, and that means that the cost and, so the cost and the number of units used is the same for both systems. So if I use exactly what I found here, call it 780, it doesn't matter if I was on the prepaid or the postpaid, I would pay the same amount. Right, and then what we look at, what is important here, you often get asked, explain when it would be most economical for each of these systems. So my prepaid graph, my blue graph, right up until 780 is below the postpaid graph. It is below that graph. So over here, the prepaid is the cheapest. Then once we get past the break-even point, you can see that the prepaid then becomes more expensive over there. So that is the meaning of the break-even point. Right, so I calculated this at 720 units. The cost of electricity on the postpaid was 716.38 and the prepaid was 716.72. The actual value when calculated algebraically, it is 719.9 units, and that will cost 719.91 for both the systems. Okay, in a test, 720 would be accurate enough. I would accept it. The prepaid option is cheapest for the household using, so prepaid was our blue graph. So for a household using 0 to 780, it would be cheaper. So 0 to 780 kilowatt hours, it would be cheaper. The postpaid is more than 780 kilowatt hours. So that is how we use the break even on 2 line graphs. The next one I want to look at is working with 2 relationships, but now we're going to look at